Okay, we're looking at equivalent fractions in this video. I'm going to do a quick diagram and a few questions, examples to hopefully help you understand equivalent fractions. So, first of all, I'm going to do a quick visual representation. I'm just going to do a quick sketch of a representation of 1/4. Okay, so I'm going to do a quick diagram. Let's say, let's make it 4 centimeters down, 4 centimeters across, 2 and 4 centimeters up. Whoop, I don't really want to knock that. 4 centimeters up, somewhere like so, and then hopefully that makes a nice box. That's not bad, is it? Let's mark on my halfway point. So my visualization of a quarter is just as if this was a square bit of paper and I'm folding it in half one way and in half another way. Okay, so there's a halfway mark there and a halfway mark here. So let's draw on our halves. Okay, so if I was to ask you to represent 1/4 in a box like this, then most people would fold it in half one way, in half another way, and then be happy to say, well, one of these smaller squares is representative of a quarter. Okay, and that's fine. That's a perfectly good way of doing it. Okay, now equivalent fractions is about different ways of representing the same diagram, the same shaded area using different numbers. Okay, so let's say instead of just putting it in half one way and in half another way, so half along there and half down there, I folded it in half one way and into quarters another way. Okay, so let's do that. I'm going to quickly split this into quarters along the top. So there and there, and whoops, there and there. Draw my line on. So hopefully you can see now, rather than being just split into 4 parts, this diagram is now split into 8 parts. So that means our denominator would be 8. Okay, now how many of them 8 parts are shaded? Well, there's 2 that are shaded. Okay, so another way of writing a quarter would be 2/8. Okay, we could split this up in lots of different ways and still represent a quarter using different numbers. Okay, now the key thing you need to know when you're representing a fraction differently using numbers is that whenever we use to get from the denominator to our new denominator, so in this case we multiply by 2, so whatever multiplication or division we do, it will always be a multiplication or division, it will not be an add or subtract. We need to do exactly the same to the top. So to get from 1 to 2, we still times by 2. Okay, so now let's have a look at a couple of questions for equivalent fractions. So let's say we started off with a fraction of 1/2. Okay, now you're asked to, grab a slightly thicker pen, you're asked to write equivalent fractions to 1/2, and they're going to give you some denominators and some numerators. So the first one might be, we're going to have 7 as a numerator. What is going to be the denominator? Okay, so we're asking for what number goes here. Okay, now hopefully from what we've said at the top, you can see, well, whatever we multiply the top by, we're going to multiply the bottom by to get the same answer. So to get from 1 to 7, we multiply by 1 times anything is itself, so 1 times 7 gives us 7. We need to multiply 2 by 7 to work out what this bottom number is going to be. Okay, well, 2 times 7 is 14. Okay, so another important thing to remember when you're looking at fractions is that the relationship between your denominator and numerator have to be the same. Okay, so we know that 1 is exactly half of 2. Okay, and 7 is exactly half of 14. Okay, so just like how we looked at these new numbers and how we got there, we could have said, well, how do we get from our numerator to our denominator? Well, in this case, we times by 2. So if they gave you 7, you could say, well, if I just times it by 2, I get the denominator. So there's 2 separate ways of getting both, getting the denominator. One is by kind of comparing the 2 separate fractions, and the other is looking at how you get from the denominator from the numerator, and then applying that for the second fraction. Okay, let's do the same. This time we have a half, and it's going to be equal to something over 64. Okay, we want to know what this something is up here. There's 2 ways you can go about this. You can say, well, what do we times 2 by to get to 64? Or we could say, well, the numerator is half of the denominator, so whatever is half of 64 must go up here. Okay, either way should lead you to the same answer. So let's go, I'm going to do it, let's do it this way. So to get from our denominator to our numerator, what we timesing or dividing by must stay in proportion. So we are dividing by 2. So that means to get to our numerator here, we also have to divide by 2. What's half of 64? That is 32. Okay, just to be consistent, what number do we times by 2 to get to 64? Well, 32. So 1 multiplied by 32, this way would still give you the same answer. Right then, let's have a quick look at one more example. We're going to have the fraction 3 over 12. Okay, I'm going to do a couple at once, and we're going to go from something over 4 and 9 over something. So we're looking for what would be written here and what would be written here. Okay. Now, again, there's multiple ways you can go about this. You could compare the denominator and the numerator, or you could compare across. So I'm going to compare across for this first one. What do we do from 12? We times or divide by to get to 4? Well, we divide by 3. So 3 divided by 3, you should be confident that anything divided by itself is 1. So that means 3/12 is equal to 1/4. Okay, now you could compare this fraction to this, or you could compare this fraction to this. Because they're all equivalent, it doesn't really matter. Let's have a look at, let's do this one to this, okay, just to show that it does not, they're equivalent, and we should be able to work it out either way. So to get from 1 to 9 is a nice easy calculation. We just times it by 9. To get from 4 to whatever goes under here, again, we're just going to times by 9. So 4 times 9 is 36. Let's just check the relationship between our denominators and our numerators to check we've done this correct. So let's have a look from here to here. What do we do? Well, 3 times what gives us 12? 3 times 4. 1 times what gives us 4? 1 times 4. 9 times what gives us 36? Well, it's 9 times 4. Okay, so that's a quick way of checking. So our answer, numerator for this one has to be 1. The denominator for this one has to be 36.